Visceral fat surrounds your internal organs, and that is exactly why it is dangerous. Unlike the fat you can see or pinch under your skin, visceral fat is hidden deep inside the abdominal cavity. It wraps itself around critical organs such as the liver, pancreas, and intestines. Because of this location, it does not behave like ordinary fat. It acts almost like a separate endocrine organ, releasing hormones and inflammatory chemicals that disturb the body's natural balance. This is not simply stored energy. This is metabolically active tissue influencing your entire system every single day. Many people judge their health by the number on the scale, but visceral fat does not always show itself clearly through body weight alone. A person may appear slim yet still carry dangerous amounts of visceral fat internally. This condition is sometimes referred to as TOFI, thin outside, fat inside. That is why focusing only on weight can be misleading. The real risk lies in what is happening beneath the surface. When visceral fat accumulates, it begins to interfere with insulin function. Insulin is the hormone responsible for regulating blood sugar levels. Excess visceral fat makes the body resistant to insulin, forcing the pancreas to produce more and more of it. Over time, this can lead to chronically elevated blood sugar levels and increase the risk of type 2 diabetes. The process is gradual, silent, and often unnoticed until significant damage has already occurred. But the danger does not stop there. Visceral fat is strongly linked to heart disease. The inflammatory substances released by this fat travel through the bloodstream, contributing to plaque buildup in arteries. This increases blood pressure and raises the likelihood of heart attacks and strokes. It is not simply about having a larger waistline, it is about what that waistline represents internally. The liver is another major organ affected. Excess visceral fat increases the risk of non-alcoholic fatty liver disease. Fat begins to accumulate inside liver cells, impairing their ability to function properly. Over time, this can progress to inflammation, fibrosis, and even liver failure if left unmanaged. Again, this process often develops quietly without obvious symptoms in the early stages. Hormonal balance is also disrupted. Visceral fat influences cortisol, the stress hormone. Elevated cortisol levels encourage more fat storage in the abdominal region, creating a vicious cycle. Stress increases visceral fat, and visceral fat worsens hormonal imbalance. Additionally, this type of fat can alter levels of leptin and ghrelin, hormones that control hunger and satiety, making it harder to regulate appetite effectively. Inflammation is one of the central problems associated with visceral fat. Chronic low-grade inflammation damages tissues slowly over time. It contributes not only to metabolic diseases, but also to certain cancers. Research shows strong associations between high visceral fat levels and increased risks of colorectal, breast, and pancreatic cancers. The connection lies in the inflammatory chemicals and hormonal disturbances produced by this deep abdominal fat. Another important factor is waist circumference. A growing waistline is often a visible sign of increasing visceral fat. While body mass index can provide a general guideline, waist measurement is often a better indicator of metabolic risk. Abdominal obesity is more closely associated with cardiovascular and metabolic complications than fat distributed in other parts of the body. Lifestyle plays a critical role in visceral fat accumulation. Diets high in refined sugars, processed foods, and trans fats encourage its growth. Sedentary behavior slows metabolism and promotes storage. Poor sleep disrupts hormonal regulation. Chronic stress maintains elevated cortisol levels. These factors combine gradually, building visceral fat over years. The encouraging news is that visceral fat responds well to proper intervention. Unlike some forms of subcutaneous fat, it tends to reduce more quickly with consistent lifestyle changes. Regular physical activity, balanced nutrition rich in fiber and protein, adequate sleep, and stress management can significantly lower visceral fat levels. Even modest weight loss can produce meaningful reductions in internal fat deposits. Understanding the danger of visceral fat shifts the focus from appearance to health. The goal is not cosmetic improvement, but internal protection. When visceral fat decreases, insulin sensitivity improves, inflammation reduces, blood pressure stabilizes, and organ function recovers. Energy levels rise, and long-term disease risk declines. The key message is simple yet powerful. What you cannot see may pose the greatest risk. Visceral fat operates silently, influencing vital systems without obvious warning signs. Taking proactive steps today protects your heart, liver, pancreas, and overall metabolic health for years to come. Diet directly influences visceral fat accumulation, and this is not a theory, it is a measurable biological reality. Every time you eat, your body makes metabolic decisions. It decides whether to burn energy, store it safely, or convert excess into fat. When dietary patterns consistently include high sugar, refined carbohydrates, unhealthy fats, and ultra-processed foods, the body shifts toward storage mode, and much of that storage happens deep inside the abdomen as visceral fat. The process often begins with blood sugar imbalance. When you consume refined carbohydrates such as white bread, pastries, sugary drinks, or sweets, your blood glucose rises rapidly. In response, your pancreas releases insulin to move that glucose into cells. However, when this spike happens repeatedly throughout the day, insulin levels remain chronically elevated. High insulin signals the body to store fat, particularly in the abdominal region. Over time, cells become less responsive to insulin, leading to insulin resistance, a major driver of visceral fat growth. Excess sugar, especially fructose from sugary beverages and processed foods, plays a particularly harmful role. Unlike glucose, which can be used by many tissues in the body, fructose is primarily metabolized in the liver. When consumed in high amounts, it overwhelms the liver's capacity to process it efficiently. The excess is converted into fat through a process called de novo lipogenesis. This newly created fat can accumulate in the liver and contribute to visceral fat storage around abdominal organs. Regular intake of sugary drinks has been strongly associated with increased belly fat, even in individuals who are not significantly overweight. Unhealthy fats also contribute. Trans fats, often found in fried foods and packaged snacks, increase inflammation and promote fat storage. Diets high in processed vegetable oils and low in omega-3 fatty acids disrupt the balance between pro-inflammatory and anti-inflammatory pathways in the body. Inflammation, as mentioned earlier, plays a central role in visceral fat expansion. The more inflamed the body becomes, the more metabolic dysfunction develops, encouraging fat deposition around organs. Portion size and total calorie intake matter, but the quality of calories matters even more. Two diets may contain the same number of calories, yet produce very different effects on visceral fat. A diet rich in whole foods, vegetables, fruits, lean proteins, whole grains, nuts, and legumes, supports stable blood sugar and reduces inflammatory signals. In contrast, a diet high in processed foods creates metabolic stress, encouraging the body to store fat defensively. Protein intake has a protective effect. Adequate protein supports muscle mass, and muscle tissue increases resting metabolic rate. When protein intake is insufficient, muscle mass can decline, lowering metabolism and making fat accumulation easier. Additionally, protein increases satiety hormones, helping regulate appetite and reduce overeating. Diets lacking in protein often lead to higher intake of refined carbohydrates, which further drives visceral fat storage. Fiber is another critical component. Soluble fiber slows digestion and moderates blood sugar spikes. It also feeds beneficial gut bacteria, producing short-chain fatty acids that improve insulin sensitivity and reduce inflammation. Diets low in fiber, common in highly processed eating patterns, remove this protective mechanism. As a result, fat storage signals become stronger. The gut microbiome itself plays a role in how diet affects visceral fat. Highly processed diets alter the balance of gut bacteria, reducing microbial diversity. An unhealthy gut microbiome can increase intestinal permeability, allowing inflammatory substances to enter the bloodstream. This systemic inflammation contributes to metabolic dysfunction and abdominal fat accumulation. On the other hand, a diet rich in plant-based foods supports a diverse and healthy microbiome, which helps regulate metabolism. Timing and eating patterns also influence visceral fat. Frequent snacking, late night eating, and constant grazing keep insulin levels elevated for extended periods. Without adequate fasting intervals, the body has limited opportunity to access stored fat for energy. Structured meal timing and balanced meals can improve hormonal regulation and reduce fat storage signals. Alcohol consumption further complicates the picture. Excessive alcohol is metabolized in the liver and can contribute directly to fat accumulation in both the liver and abdominal cavity. Even moderate intake, when combined with poor dietary habits, can accelerate visceral fat gain. Chronic dieting and extreme calorie restriction can paradoxically worsen the problem. Severe restriction raises cortisol levels, and high cortisol promotes abdominal fat storage. Sustainable, balanced nutrition works more effectively than crash diets. The encouraging reality is that dietary changes can significantly reduce visceral fat. Studies show that improving diet quality, even without dramatic weight loss, can lower internal fat levels. Reducing added sugars, increasing fiber intake, prioritizing lean protein, choosing healthy fats, and minimizing processed foods create a metabolic environment that discourages abdominal fat storage. Diet is not just about calories. It is about hormonal responses, inflammatory balance, gut health, and metabolic efficiency. Every meal is either promoting fat storage or supporting fat reduction. The choice, repeated daily, determines whether visceral fat expands or gradually diminishes. High-protein foods increase fat, burning metabolism, and this effect is supported by clear physiological mechanisms. Protein is not just another macronutrient. It plays a uniquely powerful role in regulating body composition, appetite, hormones, and energy expenditure. When the goal is reducing visceral fat, protein becomes one of the most strategic dietary tools available. The first mechanism is something called the thermic effect of food. Every time you eat, your body uses energy to digest, absorb, and process nutrients. Protein has a much higher thermic effect compared to carbohydrates and fats. Approximately 20–30% of the calories from protein are used during digestion itself, while carbohydrates use about 5–10% and fats only 0–3%. This means that when you consume protein-rich foods, your body automatically burns more calories simply processing them. Over time, this higher energy expenditure contributes to fat loss, including reductions in deep abdominal fat. Protein also plays a crucial role in preserving and building muscle mass. Muscle tissue is metabolically active, meaning it burns more calories at rest compared to fat tissue. When calorie intake is reduced without adequate protein, the body may break down muscle along with fat. Loss of muscle slows metabolic rate, making it easier to regain weight and harder to reduce visceral fat. However, when protein intake is sufficient, muscle mass is preserved, metabolic rate remains higher, and the body preferentially burns stored fat for energy. Another powerful effect of protein is appetite regulation. Protein influences several hormones that control hunger and fullness. It increases levels of peptide Y and GLP-1, hormones that promote satiety, while reducing levels of ghrelin, the hunger hormone. When protein intake is higher, people naturally feel fuller for longer periods. This reduces overall calorie intake without conscious restriction. Fewer calories consumed consistently lead to gradual fat loss, particularly in the abdominal region. Blood sugar stability is another important factor. Meals high in refined carbohydrates cause rapid spikes in blood glucose, followed by sharp drops, which can trigger cravings and overeating. Protein slows digestion and moderates the release of glucose into the bloodstream. This prevents dramatic insulin spikes. Since elevated insulin promotes fat storage, especially visceral fat, keeping insulin levels stable helps reduce fat accumulation over time. Protein also improves insulin sensitivity. When muscle mass increases and inflammation decreases, cells respond more effectively to insulin. Improved insulin sensitivity means the body requires less insulin to manage blood sugar. Lower insulin levels reduce signals for fat storage in the abdominal cavity. This hormonal balance is essential in addressing visceral fat specifically. There is also an important connection between protein intake and cortisol regulation. Chronic stress elevates cortisol, and high cortisol levels encourage abdominal fat storage. Adequate protein supports stable energy levels and reduces blood sugar fluctuations, both of which can help minimize stress responses within the body. While protein alone does not eliminate stress, it contributes to metabolic stability that supports healthier hormonal balance. Quality of protein matters as well. Lean protein sources such as eggs, fish, legumes, lentils, Greek yogurt, tofu, and skinless poultry provide essential amino acids without excessive unhealthy fats. Fatty fish offers the added benefit of omega-3 fatty acids, which reduce inflammation and further support visceral fat reduction. Plant-based proteins, when consumed in variety, also provide fiber and antioxidants that enhance metabolic health. Distribution of protein throughout the day is equally important. Consuming adequate protein at each meal supports steady muscle protein synthesis and sustained satiety. Skipping protein at breakfast, for example, may lead to stronger cravings later in the day. A balanced intake across breakfast, lunch, and dinner ensures consistent metabolic stimulation. It is important to understand that increasing protein does not mean eliminating carbohydrates or fats completely. Balance remains essential. Extremely high protein diets without sufficient fiber, healthy fats, and micronutrients may create other health concerns. The goal is adequate protein within a well-rounded nutritional pattern. Research consistently shows that higher protein diets are associated with greater reductions in abdominal fat compared to lower protein diets with the same calorie content. Even modest increases in protein intake can produce measurable improvements in body composition. Ultimately, protein works through multiple pathways, increasing calorie expenditure, preserving muscle mass, stabilizing blood sugar, regulating appetite hormones, improving insulin sensitivity, and supporting hormonal balance. These combined effects create a metabolic environment that favors fat burning rather than fat storage. When protein intake becomes consistent and balanced, the body shifts gradually, cravings decrease, energy stabilizes, muscle strengthens, insulin levels moderate, and over time visceral fat begins to decline. This is not a quick fix, but a physiological adjustment driven by daily nutritional choices. Key point: no. 4 expended in 700 words without heading fiber stabilizes blood sugar and reduces fat storage, and this single nutritional factor plays a far more powerful role in visceral fat control than most people realize. Unlike protein, fat, or carbohydrates that provide calories, fiber is a type of carbohydrate the body cannot fully digest. Yet its influence on metabolism, hormones, gut health, and abdominal fat accumulation is profound. When you eat foods rich in fiber, such as vegetables, fruits, legumes, whole grains, nuts, and seeds, digestion slows down. This slower digestion prevents rapid spikes in blood glucose. Instead of sugar flooding the bloodstream all at once, glucose is released gradually. As a result, insulin is released in a controlled, moderate manner. This matters because insulin is not just a blood sugar hormone, it is also a fat storage hormone. Frequent, sharp insulin spikes encourage the body to store excess energy as fat, particularly in the abdominal region. Soluble fiber is especially important in this process. It dissolves in water and forms a gel-like substance in the digestive tract. This gel slows gastric emptying and carbohydrate absorption. Oats, lentils, chickpeas, apples, flax seeds, and beans are excellent sources. By reducing the speed at which sugar enters the bloodstream, soluble fiber reduces the demand for high insulin output. Over time, this supports improved insulin sensitivity, a key factor in reducing visceral fat. Insoluble fiber, found in foods like leafy greens, whole grains, and vegetables, adds bulk to stool and supports healthy digestion. While it does not directly form a gel, it improves overall gut motility and prevents constipation. Efficient digestion reduces systemic stress and supports overall metabolic balance. Both types of fiber work together to maintain internal stability. Another critical mechanism involves the gut microbiome. The human digestive tract contains trillions of bacteria that influence metabolism, inflammation, and fat storage. Fiber acts as a prebiotic, meaning it feeds beneficial gut bacteria. When these bacteria ferment fiber, they produce short-chain fatty acids such as butyrate, acetate, and propionate. These compounds reduce inflammation, strengthen the gut lining, and improve insulin sensitivity. A healthy gut lining prevents what is sometimes called leaky gut, a condition where harmful substances pass into the bloodstream and trigger inflammation. Chronic low-grade inflammation is strongly linked to visceral fat accumulation. When inflammation decreases, metabolic function improves, and the body becomes less likely to store fat deep in the abdomen. Fiber also plays a powerful role in appetite regulation. High fiber foods increase satiety, helping you feel full for longer periods. Because they require more chewing and digest more slowly, they naturally reduce overeating. When calorie intake decreases in a sustainable way, the body begins to use stored fat for energy. Visceral fat, being metabolically active, often responds well to this shift. Calorie density is another factor. High fiber foods tend to be lower in calories relative to their volume. A plate filled with vegetables and legumes provides fewer calories but more bulk compared to processed foods. This allows individuals to eat satisfying portions without excessive energy intake. Over time, this reduces the overall energy surplus that contributes to fat storage. Research consistently shows that individuals with higher daily fiber intake have lower amounts of visceral fat. Even modest increases, for example, adding 10 grams of soluble fiber per day, have been associated with reductions in abdominal fat accumulation. This effect occurs even without drastic changes in total calorie intake. Modern diets, however, often lack adequate fiber. Highly processed foods remove natural fiber during manufacturing. White bread instead of whole grains, fruit juice instead of whole fruit, refined cereals instead of oats. These substitutions dramatically reduce fiber intake. As fiber decreases, blood sugar fluctuations increase, insulin spikes become more frequent, and fat storage signals strengthen. It is important to increase fiber gradually and accompany it with adequate water intake. A sudden dramatic increase may cause digestive discomfort. Gradual changes allow the gut microbiome to adapt. Hydration supports fiber's ability to function effectively within the digestive system. Fiber does not act instantly. Its benefits accumulate with consistency. Daily intake supports long-term metabolic stability. Over weeks and months, improved insulin regulation, reduced inflammation, better gut health, and controlled appetite combine to create measurable reductions in visceral fat. Ultimately, fiber works quietly but powerfully. It regulates the internal environment, steadies blood sugar, moderates insulin, nourishes beneficial bacteria, and reduces inflammation. These processes together shift the body away from fat storage and toward metabolic balance. By prioritizing fiber-rich whole foods daily, you create conditions that discourage visceral fat growth and promote sustainable fat reduction from within. Omega-3 fats reduce inflammation and abdominal fat, and their impact on visceral fat goes far beyond basic nutrition. These essential fatty acids are not produced efficiently by the body, which means they must come from diet. Found in fatty fish such as salmon, sardines, and mackerel, as well as in flax seeds, chia seeds, and walnuts, omega-3 fats play a regulatory role in metabolism, hormonal balance, and cellular health. Their influence on visceral fat is largely connected to their powerful anti-inflammatory properties. Visceral fat is metabolically active tissue. Unlike subcutaneous fat, it releases inflammatory cytokines, chemical messengers that promote chronic low-grade inflammation throughout the body. This persistent inflammation interferes with insulin signaling, disrupts metabolic processes, and promotes further fat accumulation in the abdominal cavity. Omega-3 fatty acids counteract this process by reducing the production of inflammatory molecules such as tumor necrosis factor alpha and interleukin-6. When inflammation decreases, insulin sensitivity improves, and the signals that drive fat storage begin to weaken. One of the key mechanisms through which omega-3 fats operate involves cell membrane structure. Every cell in the body is surrounded by a membrane composed largely of fatty acids. When omega-3 levels are adequate, cell membranes become more flexible and function more efficiently. This flexibility improves insulin receptor function, allowing glucose to enter cells more effectively. When glucose is used properly for energy, the body requires less insulin, and lower insulin levels reduce the likelihood of visceral fat storage. Omega-3 fats also influence gene expression related to fat metabolism. They activate certain receptors such as peroxy, some proliferator-activated receptors PPARs, which regulate how the body processes fats and sugars. Activation of these pathways encourages fat oxidation, the burning of stored fat for energy rather than fat storage. This metabolic shift is particularly important in the reduction of deep abdominal fat. Another significant benefit of omega-3 fatty acids is their effect on liver health. Excess visceral fat is often associated with non-alcoholic fatty liver disease, a condition where fat accumulates in liver cells. Omega-3 fats help reduce liver fat content by improving fat breakdown and decreasing the synthesis of new fat in the liver. As liver function improves, overall metabolic regulation becomes more efficient, indirectly supporting reductions in visceral fat. Hormonal balance is also positively influenced by omega-3 intake. These fats help regulate cortisol levels, the primary stress hormone. Chronically elevated cortisol encourages fat deposition in the abdominal region. By reducing systemic inflammation and stabilizing metabolic processes, omega-3s help moderate the stress response, which may limit stress-related fat accumulation. Appetite control can also improve with adequate omega-3 intake. Some research suggests that these fatty acids influence leptin, the hormone responsible for signaling fullness. When leptin sensitivity improves, the body better recognizes satiety signals, reducing overeating. Lower calorie intake over time contributes to gradual fat reduction. It is important to understand that omega-3 fats must be balanced with omega-6 fats. Modern diets often contain excessive omega-6 fatty acids from processed vegetable oils and fried foods. While omega-6 fats are not inherently harmful, an imbalance between omega-6 and omega-3 promotes inflammation. Increasing omega-3 intake while reducing processed foods helps restore this balance and supports anti-inflammatory pathways. The most potent forms of omega-3s for visceral fat reduction are EPA-eicosapentaenoic acid and DHA-docosahexaenoic acid, primarily found in marine sources. Plant-based sources provide ALA, alpha-linolenic acid, which the body can convert into EPA and DHA, though conversion rates are limited. Including fatty fish several times per week is often an effective strategy for achieving adequate levels. Consistency is crucial. The anti-inflammatory and metabolic benefits of omega-3 fats build gradually. Short-term intake may not produce dramatic visible changes, but sustained consumption supports long-term metabolic improvement. Over months, reductions in inflammation, improved insulin sensitivity, better liver function, and enhanced fat oxidation contribute to measurable decreases in visceral fat. Omega-3 fats are not a standalone solution. They function best within a balanced dietary pattern that includes adequate protein, fiber, and whole foods. Combined with physical activity and stress management, their effects become more pronounced. Ultimately, omega-3 fatty acids address one of the core drivers of visceral fat accumulation, chronic inflammation. By calming inflammatory pathways, improving cellular communication, enhancing fat metabolism, and supporting hormonal balance, they help shift the body away from fat storage and toward fat utilization. Through regular, mindful inclusion in daily nutrition, omega-3 fats become a strategic component in reducing dangerous abdominal fat and restoring metabolic health. Gut health plays a key role in fat loss, especially when it comes to reducing visceral fat. The digestive system is not simply a food processing tube. It is a complex ecosystem containing trillions of microorganisms collectively known as the gut microbiota. These bacteria, viruses, and fungi interact continuously with your metabolism, immune system, and hormones. When this internal ecosystem is balanced and diverse, it supports healthy weight regulation. When it becomes imbalanced, it can promote inflammation, insulin resistance, and abdominal fat accumulation. The gut microbiota influences how efficiently your body extracts energy from food. Certain bacterial strains are more efficient at breaking down carbohydrates and producing absorbable calories. If the balance of bacteria shifts toward strains that harvest more energy, your body may absorb more calories from the same amount of food. Over time, this can contribute to fat gain, particularly in the abdominal region. Studies have shown that individuals with obesity often have a different microbial composition compared to lean individuals. Inflammation is another major connection between gut health and visceral fat. An unhealthy gut lining can become more permeable, a condition sometimes referred to as increased intestinal permeability. When this happens, small particles such as lipopolysaccharides from certain bacteria can enter the bloodstream. The immune system reacts to these particles, triggering chronic low-grade inflammation. This inflammation interferes with insulin signaling and promotes fat storage, particularly around internal organs. A healthy gut barrier prevents these inflammatory substances from entering circulation. Fiber-rich foods, fermented foods, and a balanced diet strengthen the intestinal lining and promote beneficial bacteria growth. When inflammation decreases, insulin sensitivity improves. Improved insulin sensitivity means the body uses glucose more effectively rather than storing it as fat. Over time, this helps reduce visceral fat deposits, short-chain fatty acids produced when gut bacteria ferment dietary fiber play a protective role. Compounds such as butyrate, acetate, and propionate help regulate appetite, reduce inflammation, and enhance insulin sensitivity. Butyrate in particular supports the health of colon cells and strengthens the gut barrier. These fatty acids also influence hormones related to hunger and satiety, including GLP-1 and peptide Y, helping control calorie intake naturally. The gut also communicates directly with the brain through the gut-brain axis. This communication system involves neural, hormonal, and immune pathways. When the gut microbiota is balanced, signals related to appetite, stress, and metabolism remain stable. However, imbalances can disrupt these signals, leading to increased cravings, emotional eating, and poor dietary choices. Chronic stress further disrupts gut bacteria balance, creating a cycle where stress promotes gut imbalance, which then worsens metabolic function and fat storage. Diet strongly influences gut health. Diets high in processed foods, refined sugars, and artificial additives reduce microbial diversity. Lack of fiber deprives beneficial bacteria of their primary fuel source. Over time, harmful bacteria may dominate, increasing inflammation and metabolic dysfunction. In contrast, diets rich in vegetables, fruits, legumes, whole grains, nuts, and seeds promote a diverse and resilient microbiome. Fermented foods such as yogurt, kefir, sauerkraut, kimchi, and other naturally fermented products introduce beneficial bacteria into the digestive system. These probiotics can help restore balance, though they work best when combined with prebiotic fiber that feeds them. Together, prebiotics and probiotics support a healthy internal environment conducive to fat loss. Sleep and physical activity also affect gut health. Poor sleep alters microbial balance and increases inflammation. Regular exercise has been shown to increase beneficial bacterial diversity and improve gut barrier integrity. These lifestyle factors interact closely with diet to influence visceral fat levels. Antibiotic overuse can disrupt the microbiome significantly. While antibiotics are sometimes necessary, repeated or unnecessary use may reduce beneficial bacteria populations. Recovery of microbial diversity takes time and is supported by nutrient-rich, fiber-dense diets. It is important to understand that gut health does not produce instant visible changes. Improvements occur gradually as bacterial populations shift and inflammation decreases. However, these internal changes create conditions that favor fat burning over fat storage. When the gut functions optimally, metabolism stabilizes, hunger signals regulate, and energy balance improves. Visceral fat thrives in an inflammatory, hormonally disrupted environment. By supporting gut health, you directly address these underlying drivers. A balanced microbiome reduces inflammation, enhances insulin sensitivity, improves appetite control, and strengthens metabolic resilience. Ultimately, gut health serves as a foundation for sustainable fat loss. Rather than focusing solely on calorie restriction, nurturing the internal ecosystem supports long-term metabolic harmony. When the gut is healthy, the body operates more efficiently, and the reduction of dangerous abdominal fat becomes a natural outcome of restored internal balance.